we have a bullet of mass 0.1 traveling horizontally with speed 150. It enters a block of wood which rests on a smooth horizontal table. The bullet emerges from the other end of the block with a speed of 100. The block is mass 2. Find the speed of the block it's going to move after impact, and find also the impact imparted by the bullet. So we're looking for impulse. So this is a closed system with no external forces, so the momentum before will have to be equal to the momentum after. So before will have to be equal to after. So what is the momentum before? Well, it's mass times, we'll take u1 as the, we could take u2 if we wanted, or v1. It doesn't really matter what you call it, once you know what you're doing. So we have the mass afterwards, and we have the changing velocity of the bullet, and we have the mass afterwards and the changing velocity of the block. So we have the bullet and the block, and we have the bullet and the block. Okay, let's see the momentum before. The mass is 0.1 and the speed is 150, and the mass is 2 and the speed is 0. The mass afterwards 0.1, the speed is 100, and the mass afterwards is still 2, and the speed is what we're looking for, so we'll just call it v now. So we have a tenth of 150 is 15. That's equal to a tenth of 100 is 10 plus 2v. So 2v equals 5. So the velocity is 2.5 meters per second for the block afterwards. Let's have a look at the impulse on the block. So we have mv minus mu. So on the block, the mass was 2 and its velocity is now 2.5, and it was at rest, so just 5i Newton seconds for the impulse on the block. What about the bullet? What would you expect to happen here? The impulse on the bullet is equal to 0.1 by 100 minus 0.1 by the 150. So we have 10 minus 15, which is equal to minus 5i. Okay, it's 6c. These really an easy ones to start. The impulse here, 0.125 m by the final velocity minus m by the initial velocity, which you can see is 0. So 40 by 1/8 is just 5i in Newton seconds. Second, we have a hurling ball of mass 1/4, so 0.25. It's coming towards a player, so you can have it going whatever direction. Let's have it going in this direction. It comes towards a player at 40 meters per second. U is equal to 40. The player hits it so that it leaves us hurley at 20, so v is equal to 20. Find the magnitude of the impulse imparted to the ball by the hurling. So we're going to have m, which is 0.25, times 20, which is the final velocity, minus 0.25 by 40, which was the initial velocity, and 1/4 of 20 is 5, 1/4 of 40 is 10. So we're going to have a minus spot the mistake. Minus 40, it's going back the other direction. So that's going to be plus 10. So we get plus 15. Just be careful. I told you to be careful, and I didn't follow my own rules. And that's in Newton seconds. So a hammer of mass 4 kilos. So we have a hammer. M is equal to 4. Used to drive a 1 kilo wooden stake. So we have a stake. Mass is equal to 1. So we have a closed system here with two things happening. So we're looking at the momentum being the same before and after. The hammer immediately before impact has a velocity of 2. And the stake is obviously at rest. So its velocity, or you can call it U, is equal to 0. Find the speed of the stake immediately after impact when the hammer has come to rest. Okay, so before are these two. We have mv, so 4 times 2 plus m, which is 1 times 0. That's what's going on before. Then that has to be equal to what's happening afterwards. And what we're told is the hammer has come to rest. So that's going to be my 4 times 0. And then we have the mass of the stake, and we're looking for its velocity. So we have 8 is equal to V, quite simply, because we have 2 zeros. And that is in meters per second. Now find also the impulse imparted to the stake and the hammer. Okay, so impulse mv minus mu. The hammer's going down in this direction, so we're actually looking at J here, aren't we? Hammer's going down in this direction, so we have 4, and that would be negative J to begin with, going down at a speed. What speed was it going? 2. It's going at a speed of 2. So that would be after part. That would be the before part. The after part is that it's actually come to rest, so it's 4 by 0 minus the -2 is the negative direction, -2, so that's actually going to give me 8 in the J direction. That's the hammer. What about the stake? I should do it down here because that's velocity. The stake is 8, but it's going down in that direction, so that's a -8. So my impulse mv minus mu, well, it was at rest, so the second part is going to give me a 0, and the first part is just going to be my mass, which is 1, and my speed, which is going down at 8 in the J direction. So we're going to have -8 in the J direction, which tallies with the +8 in the J direction for the hammer.